Solving systems of equations using elimination. When we used substitution, we tried to replace one variable in an equation with information from a second equation. When we use elimination, we are trying to completely eliminate one variable so we can solve for one variable and then solve for the other. For example, if we have 5x plus 4y equals 6 and 2x equals negative 5y minus 1. When you first look at this, it's not easy to solve for y. It's not easy to solve for x. It's not easy to solve for x. It's not easy to solve for y. So solving either of these for one variable is going to give us a bit of a mess. So instead of doing that, let's try to make one variable in each equation match. What I mean by that is if we have 5x here, let's see if we can get something between the 5x and the 2x that matches. I'll show you what I mean. The first thing we need to do is make sure that all of our variables are lined up. I have the y on the right side for the second equation. I have the y on the left side for the first equation. So that doesn't match up. Let's move this over so at least our two equations are matched. So that's going to look like 5x plus 4y equals 6. And this is going to look like 2x plus, we have to move that 5y over, so we do that by adding. So plus 5y equals negative 1. At least now things are lined up. Nothing matches though. Our goal is going to be to get one of the coefficients to match on either the x or the y. It does not matter which one, just pick one. The easiest way to make them match is to just multiply by the reverse number. So you're looking for the least common multiple. If you can't think of the least common multiple, any common multiple will work. If I could make this 10x and this 10x, then I would be able to continue with my elimination. It's also better if one of them is positive and one of them is negative, because then I can just add my two equations together. Let me show you what I mean. If I multiply this entire bottom by 5, and this entire top by negative 2. Then we'll get negative 2 times 5x is negative 10x. Negative 2 times positive 4y is negative 8y. Negative 2 times positive 6 is negative 12. 5 times 2 is 10x. 5 times 5 is 25y. 5 times negative 1 is negative 5. At first glance, it might look like we just made this a whole lot more complicated, but something fancy is about to happen. When we add right here, negative 10 plus 10. Negative 10x plus 10x, that goes to 0, and the x's have now been eliminated. That's why this is called the elimination method. We have eliminated the x variable. Negative 8 plus 25, that is 17. Negative 12 plus negative 5, that's negative 17. 17y equals negative 17 is what we're left with. We can solve that. We can divide both sides by 17 and we can get y equals negative 1. Well, now we found y. Now we need to figure out the value of x. Let's use this one. It's a little bit less complicated for x than this one, I think, so I'll use this one. So we have 2x minus, equals, there we go, negative 5y minus 1. I like to always go back to the original. I think that y should be negative 1, so let's put that in. So 2x equals negative 5 times negative 1 is positive 5. So that means 2x equals 4 and x equals 2. So now I have my solution. I think it is 2, negative 1. So let's check that back in our original equation. I used this equation to find x. So I'm going to use this equation to check it. So we have 5. In place of the x, we have a 2. Plus 4. In place of the y, we have negative 1. 5 times 2 is 10. 4 times negative 1 is negative 4. 10 minus 4 is 6. We got that to work. So that means our solution of 2, negative 1 is right for this systems of equation. Let's try again. Let's say that we have 2x minus y minus 5 equals 0, and 10 equals 4x minus 2y. Now when you look at this, you might say, oh, the y is almost by itself. Maybe I could use substitution. Yes, you could. You could solve this for y equals, and you could substitute that in. That would be fine. I want to do a few more elimination practice questions, so let's use elimination. These are almost lined up, but this minus 5 right here doesn't need to be with the x and the y to make it match this one. So I'm just going to do some rearranging. I'm going to just move this 5 to the other side, and then we will have 5. And I'm going to, instead of saying equals 5, I'm going to say 5 equals so that it lines up with the 10. And this one, we didn't change. There we go. Now we said that if we want to use elimination, we have to make the coefficients of one variable match. They almost match here. I have 2x, I have 4x. I can make those match by multiplying the top equation by 2. If I multiply the top equation by 2, we get 5 times 2 is 10. 2 times 2x gives us 4x. 2 times negative y is minus 2y. I did not change the bottom equation. This one stayed the same. Now before we try to solve this by doing our addition or subtraction for elimination, notice these are the same line. So if you were to do your elimination, if you were to keep going, you're going to eliminate both equations, which means these are the same line. And there are infinitely many solutions. Let's try again. Let's look at negative 2x plus 3y equaling 5, and negative 4x plus y equaling negative 5. Lots of different ways to go about this. You could solve this for y right here and use substitution into this one. You could multiply the entire bottom equation by 3 to get these to match. You could multiply the entire top with the 2 to get these to match. It does not matter which way you go about it. You'll get the same thing each way as long as your algebra is correct. So let's multiply the whole top. I like to add to eliminate, so that means I need 1 to be positive and 1 to be negative. So I'm going to multiply the top by negative 2. If I multiply the entire top by negative 2, this is going to go to negative 2 times negative 2 is positive 4x plus negative 2 times 3. There we go. Negative 2 times 3y is going to be minus 6y equals negative 2 times 5 is negative 10. And then nothing is going to change in our bottom. So this just comes straight over negative 4x, making sure that we have everything nice and lined up. There we go. Notice the x's are lined up, the y's are lined up, and then the equals, the constant values are lined up. Now we can add 4x plus negative 4x, that's 0, that goes away. Negative 6y plus y, well, negative 6 plus 1 is negative 5. Negative 10 plus negative 5, that's going to give us negative 15. Divide both sides by negative 5, and we get y equals 3. I always like to go back to the original equation. It doesn't matter if we use this one or this one. I need to find x. Neither one of them looks particularly easy to use, so how about we just use this one, negative 4x plus y equals negative 5. We think that the y value is 3, so let's replace that y with a parenthesis, and we'll put in a 3. That gives us negative 4x. Subtract our 3 from both sides. Negative 5 minus 3 is negative 8. divide both sides by -4, and we get x equals 2. We need to check it. Since we used the bottom equation to solve for x, let's check in the top. So we have -2, leave our parenthesis, plus 3, leave our parenthesis, equals 5. We think that the x value is 2, so 2 goes in our parenthesis where the x was. We think the y value is 3, so 3 goes in our parenthesis where the y was. -2 times 2 is 4. Negative times a positive is a negative. 3 times 3 is 9. -4 plus 9 is 5, so 5 equals 5. We got it. That means our solution of 2, 3 is right.